Hello everyone, it's Ian Coglan here. I'm just going to demonstrate what I was going to use in Nessie. Now this here is a Magura hand throttle. It's actually a 5k ohm potentiometer. I can't hold that on all the time to hold it at a regular speed, so I've replaced it with a 5k ohm potentiometer. This here is UFO's circuit that I used to light the CFL bulbs up in one of my first videos. It's exactly the same circuit. I've got exactly the same oscillator, except this is a 5k ohm one instead of a 50k ohm one. This one here shows the volts that's actually going to the fan, and this the regulator is showing the volts that's actually going to the oscillator. Here it's 24 volts. That's the on-off switch. The amps that it's drawing, they're common, 12 volts, 24 volts. I'm only going to run it on 24 volts because the motor has to be less than 200 watts. And as I'm going to demonstrate now, it's actually only going to be less, about 180 or 190 watts. The 36 volts I'm not using. This here is showing what the volts are in the battery that it's being drawn. That's the positive and the negative there. This one over here is showing what I'm actually drawing from, producing from the motor. This one actually comes off the generator coils. Here it's showing the revs that it's doing. I've got it on continually, so I'll see continually what the revs are. Now what I'll do, I'll start it up now. This here is what I'm going to use to slow it down. I'll just start it up now. The potentiometer slows it right down from nothing to the duty cycle, which is 99%. At the moment it's running at 2059 revs, 57 is gradually increasing. The amps draw there is 1 amp. The volts in the battery is 24.8, it was 5.1 before I started. In here it's showing 24.1 volts, that's the input. And that's because I've got a diode there that is showing a little bit less than this one. That one now is showing that it's 14 volts going to the oscillator. This is 12.1 volts going to the fan. I said the revs now is up to 2050. The amp draw is still just 1 amp. Now I'll put a load on the motor. It's way off. The amps is way off. But you'll notice that what the volts drop down to 21, 23 volts. The revs on the motor is, can't keep it on there, it's 1239. The input, the output from the generator mode is 23 volts. It's a bit less now because the battery dropped down a bit. I should have left it on before, but I'll show again. Drops right down to nothing. The motor, it doesn't want to stop, so we can work out from that what the watts of this motor is now. I'll switch it off. So everyone, it's Ian Coglan again. I've just modified this the circuit here to demonstrate putting the input, these two wires together. That's the two generator together. The generator feeding back into the motor. I've swapped the wires around there to connect the motor up correctly. Again, this is the volts in the battery is 25.3, and everything else is exactly the same. So I'll start it up now. The res now is 994. It's actually going down a bit because I don't know why that is. Perhaps the battery's too small. But I'll put the load on it again and you'll see. I can stop it easier. It's drawing over 8 amps when I'm nearly stopping it, and it's easy to stop using this controller. So that's all I have to say. I couldn't read the output voltage because it's going back into the motor.